Welcome to the answer video of the question about the milk factory. My name is Sharon and I will explain you how to solve this question. Were you able to help the CEO of the milk factory? She was wondering which way of tubing is most efficient for the transport of fresh milk, a cylindrical or a rectangular pipeline. The first question asks you to calculate the velocity in a cylindrical pipeline with a length of 20 meters and a diameter of 4 centimeters. I've already made a sketch and wrote down all the data given. The question states that you need to use the Blasius equation, which is the following equation and which depends on Reynolds number, which is of course this. If we fill the Blasius equation in the Fanning pressure drop equation, we get the following equation. Of course, we can fill in Reynolds number in the Fanning equation, and by doing this we can simplify the equation and are able to eliminate the velocity. We have all the data we need, so we can now easily calculate the velocity, which is 0.5 meter per second. But was it reliable to use the Blasius equation in this situation? Therefore, we have to check Reynolds number. For Reynolds number, we will find a value of 19,500 if we use the calculated velocity of 0.5 meter per second. So, it is reliable to use the Blasius equation because this equation can be used for smooth cylindrical pipelines with a flow corresponding to a Reynolds number between 4,000 and 100,000. So it is reliable. To compare cylindrical and rectangular pipelines, we have to calculate in the next question the velocity in a rectangular pipeline. Here you see a sketch and all the data that is given. Of course, in this situation we cannot use the Blasius equation because we have a rectangular pipeline. So we will use the normal Fanning equation. For a rectangular pipeline we can calculate the hydraulic diameter because this is what we need before we can use the Fanning equation. The Fanning equation is this, which depends on Reynolds number, which also contains the hydraulic diameter, as you can see here. If we eliminate the average velocity, we will find this equation. But we see that we have two unknowns now, namely the velocity and 4f. But 4f depends on Reynolds number, which depends on the velocity. So this is a difficult situation, so we need to iterate. For the first iteration, a good estimation is to use the velocity found in the question about the cylindrical pipeline, which was 0.5 meter per second. Using this velocity, we can calculate Reynolds number and use the graph that shows for smooth pipelines the corresponding value for 4f for a specific Reynolds number to determine the value for 4f. And thereafter we can fill in 4f in the definition for the average velocity, here, and find a new value for the average velocity. With this founded average velocity we can calculate again Reynolds number and again determining 4f and so on. Finally, we will find a value for the average velocity in the rectangular pipeline of 0.49 meter per second. So which pipeline will be most efficient? The cylindrical pipeline with a velocity of 0.5 meter per second or the rectangular pipeline with a velocity of 0.49 meter per second? Well, of course the one which transports the milk the fastest, which is the cylindrical pipeline. Thank you for watching this video, and if you still have questions you can always ask them on the forum to get help from us or other participating students. Good luck during the next chapter of this week.